more info. All right. So let's get going. So, as you know, my name is Greg. I'm a CTO in Cobiro, but it's just a fancy title. I'm a developer at heart as well. I've been coding for over 14 years already now, mostly full stack, both backend and the front end. This is why with the latest, SPA going more forward with business logic that you can keep in a browser, and you can actually, use a computer browser to do some computations and rendering of the websites that became a lot more reactive. There is a trend of moving a lot of stuff from backend into front end. And I'm part of that trend. I really believe that we can benefit in front end using some of the tricks that have been used in backend for some time now. And one of them is event-driven architecture. I'm going to bring it some example and some theory, but let's start with the basics. So let's start with what you will learn in today's session. In today's session, we're going to be talking about coupling and cohesion. This is yet simple but quite advanced topic to understand and master in your code base in any programming language. So but it's very important to actually understand as soon as you get bigger than just a to-do app, because Angular is made for all kinds of projects, from to-do apps or tutorials that do very simple stuff, all the way up to enterprise level apps. And the bigger you grow, the bigger is your app, the more important it actually becomes. So I'm going to give you some examples that are maybe a little bit tedious, but generally it will speak for itself. So then we are going to talk about event-driven architecture. So we're going to talk what is it, how does it work, and what are the benefits of it. So let's get going. Let's start with the coupling and cohesion. So this is like an image from Wikipedia. If you Google event cohesion in programming languages, you will find that picture for sure. The idea is that the diagram picture on top is showing a good combination of both, because these are very related topics. So loose coupling and a high cohesion. This is what you want to go in your modules, in your apps, in your libraries in Angular. And then on the bottom, you have a not so good approach, which is called high coupling, low cohesion. So first, let's start with the easy one, which is coupling. Coupling means so if you look at the cubicle right here on the left and on the right, these are two different modules. Technically, if they're two different modules, they should be self-contained and independent. So coupling is how many communication points you have between the modules. So loose coupling means you have one, maybe two. High coupling means you have many. You don't want to do that. You don't want to do it, because if you have a high coupling, it means moving things. It means refactoring one module actually affects the other module. You can't just simply copy from one directory to another, because you have to update your import parts, and obviously your IDEs can manage a lot of that for you. But it also depends on the size of the project. I mean, I use pretty good IDE, but I tend to have a problem with that too, because it's just too many files. So the connection is really important. So ideally, you would have zero connection between the modules, and I'm going to talk about that a little bit later. It might sound a little bit abstract, but it's very simple actually. So loose coupling means few connection points, and you can use different design patterns for that. You can use facade. So an example of that could be that these two green points are the facade. So these are like a public-facing class. So it's like a public API of your whole module, right? So everything related to that module is behind that class. That's one way to go about it, but one is still a coupling. So still you will have to do a little bit of a refactor. And this is a simple example when you have one-to-one relation, but obviously normally you would have one-to-many relationships. So then this module can be coupled to many other ones. This is just an example. So things get really nasty really fast. Then the second approach is called cohesion. It means how the dots inside of the cubicle are connected. An idea is that statistically, people agreed in computer science that if dots are connected, it might mean it's actually a good thing. It's because this could foster reusability of classes. It could mean good single responsibility, and things like this. So you can see here, you don't have too many points. So it could mean it's good, but it also mean it's not as good if, it depends what's inside this class, of course. But technically, this point has relation to three others, and it's nicely structured, and then this one has to treat another ones, and so on. So it's usually fine. I mean, it's worse when one point is connected to everything. That could be a sign of a bad thing. But generally, high coupling means classes know about its siblings. It doesn't know about outside world. And in here, well, this is not the case. That's totally another story. Those classes know about each other. So it's considered bad, actually. Okay, I hope that's sort of clear. So we can talk about coupling and cohesion, and then, but what does it really mean? Like, what are the consequences of that? So one of them is called spaghetti code, sometimes called lasagna code. An idea is that, so inside the module, you should probably contain layers as well. So typical architecture could be an application layer, domain layer for the business logic. Then you would have infrastructure layer for communication with the outside world, like REST API or whatever. You could have UI layer with components. So in general, if you have, let's say, a component, so UI layer in module A has a reference to service in module B, you not only create a coupling between module A and module B, but you also create the spaghetti code because you skip the layers in between. And then when you have a connection like that, then you might have a connection the other way, and that actually starts looking like spaghetti when you start visualize it in the graphs, hence the name spaghetti code. And that's really bad thing, because if you ever need to refactor anything, it's getting really, really difficult. I have a whole video about spaghetti code. You can check my YouTube. Then another issue is cognitive load. So I work in one module and I should be expert in that module, but it's not the case, because if I have a high coupling, I have to be aware of other modules as well, all the connections. So suddenly it's not only one thing I should take care, I should start knowing all about all the systems. And that's higher cognitive load. I have to, as a developer, have a higher, longer onboarding in a system and understand more things, pretty much. And that's not really desirable. You should actually unfold knowledge as you go in a company, in my opinion. Then the fragility. This is actually a very interesting case. Whenever I go on a meeting with product managers or something like this, or someone responsible for project or product, they might complain about, oh, we created a lot of bugs. And then I would ask them, what kind of bugs? What caused the bug? And then they say, well, it's funny because we were working on module A and suddenly module B stopped working and we didn't touch it. So we don't know why it happened. Well, it happened because your architecture is fragile. It means changes in one place break the other part. And that's very dangerous, because as a developer, I think I'm doing a real, genuine good job. Because I just changed one piece somewhere. I've seen it so many times when developers just remove one line of code because that's not important, it's not connected to anything, but little they know that they actually broke another module. So be aware of that. And having a tight coupling creates fragility in your system. And then also there is a maintainability issue. Obviously, I have to maintain much more code, and small changes affect so many places. I might start having code smell called the shotgun surgery, which means if I wanna do simple functionality. Just let's say add one extra feature to my class. But in order to do that, I have to affect 5 other places. That's a shotgun surgery. You just do git status whenever you wanna push that feature. And if you touch more than 2, 3 files, and it's a really tiny feature, you might have a problem as well. So your maintainability is pretty high. And we know it costs money to build and maintain the software. Actually, it costs more money to maintain it rather than build it first. So yeah, it's a big issue. And then also the complexity. You might start getting things like if statements inside the code, and you can start having some, issues regarding the polymorphism of your object-oriented programming paradigm. So it's a nasty place to be in. So the complexity starts growing, and you also want to avoid that at all costs. So I have an example. Actually, if you go to github.com Kobiro IDA, that's a public repo. You can see the example. I'm going to be pushing more code soon, so you're going to see more sophisticated case of that. But I mean, you can go around and do it. We actually want to open source that piece of software. EDA stands for Event-Driven Architecture. But today, I'm not going to show you that silly example. I'm actually going to show you something more sophisticated. So let's have a look at actually what we build at Kobiro. So this is a website builder. This is one of the apps. We have many apps in Kobiro. So, but it's a really sophisticated one. You have a lot of functionalities. I'm not going to go into that. What's important is I would like to implement something very simple. I would like to trigger a user who is on some plan, which is like a free plan, and trigger him to upgrade for more expensive plans because he wants to use the feature which is more, it's on a higher plan, right? So I want to upsell the user to buy more things on my application. Now, the issue is it can be done easy and nice using naive approach, but then I'm going to show you the consequences. So first, let me show you the functionality. So I have an upgrade button, right? Whenever I click the upgrade button, I want to get that table. So it's a model in which I can choose the plan and then pay for it. Now, this is easy. It's just a button. Now, here it's a little bit more difficult because if I am on that plan that is higher paid, I shouldn't see this footer at all. But since I'm on a starter plan, I need to show it and then have that trigger as well. So this is easy, right? You think about it, hey, what's so wrong? I mean, it's probably Angular material dialog. So all I can do is to put the dialog service inside of my whatever component is it. It's called builder, and then just call open on it. Well, yeah, sure, you can do that, but it has a lot of consequences actually. So before we get to that, I want to show you a little bit more. That's in the builder, right? But what if I go to another app? This one is called Google Search Ads. And if I click that button, I also want to get the same model. So you either need to duplicate that logic in 2 different places, or you need to come up with some smarter approach. So let me show you a diagram. An idea is I have 2 modules, Builder and Google Ads. And then I have this plan model. So since these are 2 different independent modules and they are loaded through lazy loading, what I can do is to just duplicate it. So I can have a logic here and the logic there. But this is duplication of code. So it's called, we have a rule called dry, don't repeat yourself, while we're clearly repeating ourselves. And then obviously this doesn't scale because the more apps I add, these are only 2 examples, but I can add it anywhere I want. Then I have to call it in so many places. So it's the problem will only grow. The other approach could be I could have it in some like a global scope, like an app scope, and have it there. Yeah, but that's also not so neat because then the app knows about these modules. I cannot simply remove them easily. It's a bit of a problem as well. I still have to communicate with the parents somehow. So I hope you're still with me on this. So this diagram is not very clean because of those very reasons I just mentioned. we're going to have some Q&A later so we can ask more questions. So there must be a better way. So in order to do a better way, I need to come up with some sort of requirement for it. So what I would like to do is I would like to have the functionality in another way. So for example, it doesn't matter if the builder. I would like to be able to remove it because we're using feature flags, right? So the idea is that, hey, I want to be able to hide it or show it all together. And right now it's not going to be very possible because the plan will stay. So it's not also valuable. So I would like to have it so self-contained that even if someone comes in and removes this or removes this, things will not break. And in a normal standard way with the service dialog, it will cost me a lot of trouble to actually go to all those modules and make changes. And I would like to make changes in one place, not in so many places. So what can I do? Well, obviously, you probably guessed that you would go with event-driven architecture. So let's start with a bit of a theory. What is event-driven architecture and how can we utilize it? So first of all, it's very important to understand that it is an architecture, and the architecture that is based on events, which means you want to have a loosely coupled, high cohesive modules. So then you also need to understand it's also a strategic framework, which means it's not something like NGRX. Actually, it can and should work with NGRX or whatever state management system you want to use. It doesn't really matter. It's a strategic framework, which means it still gives you the benefit of using whatever like inner architecture you want to use in your modules. It's just a messaging system, if you will. An idea is that you want to make a reactive stuff. You could even use it with micro frontends. The idea is that you have modules that coexist. They don't know about each other, but then they can react to changes in another module. So the idea is very simple. You have events, and those events are the communication mechanism between the modules. So you have to shift your mindset. You cannot think in terms of, I have something that I need to call and execute. No. It's asynchronous. It's asynchronous in nature, which means something can happen at any time. And then all you have to do is whenever the event comes, because you subscribe to it, you react to it somehow. You might totally ignore it. You might actually change something in your UI. You can switch some things inside the state. You can do whatever you want to do. But an idea is it's not store. It's not something that contains and persists an information. It's just a messaging system. It's like a notification in your browser. But because it's asynchronous in nature, you have to worry about things like eventual consistency. So you can't expect that you're going to press the button and immediately something will happen as an effect of that. It's actually going to dispatch something in the cloud, and then things will start appearing with a small delay. So, but it's really powerful. So here is an example. So I might have things like core libraries, could be for authentication, could be events. It could be some shared libraries for my UI, like Angular Material or whatever. So these are separate. But then I have my feature modules. So this one contains state, so it could be using NGRX. Here I have a command query segregation. That's another way of going. I'm not going to talk about this architecture. Actually, I'm probably going to talk about it on future NGCanions. But generally, it's a little bit more sophisticated architecture you can use. And then you have a command query responsibility segregation, even more advanced architecture, pretty common on backend, but it's actually very powerful in frontend as well. We can talk about it also some other time. But generally, what I want you to understand is you have 3 different modules, and those modules don't know about each other. You see, there is no connection. And they can decide on whatever architecture they want to use. Even if you want, you could use just a smart component. It doesn't matter. So you can choose whatever architecture you want to do. But let's say something happens in this place, and I want to invoke a functionality on another place, but not directly. I would like to tell my system that, hey, something happened, and then let the other people subscribe to this event, whatever that something might be, and then react to it if they want or if they don't want, but let them decide what to do in such an event of the situation. So what's happening is we need a communication infrastructure service called bus, application bus, and that bus does not contain an state. It's just a mechanism of communication. For example, it's a replace subject, or it could be behavior subject. RxJS works very well for it. Actually, in our case, I believe we use replace subject. So module on top, oh, sorry, and then you have two more very important things. One of them is dispatcher, and one of them is handler. The difference is that dispatcher dispatches an event, and handler handles the event. So it's two-way communication. So dispatcher can dispatch an event, which is a very simple class. It could be even an interface. And then these two modules can subscribe to it. And whenever that happens, with the slight delay, it will receive that event. And now these two modules can react to it, can do whatever they want to do. An example could be, I don't know, maybe the top one is responsible for products, and this one is the product category. Or let's say this is a product category, this is a product, and this is the product variant. You know, like a typical e-commerce. So if I remove the product category, I want to shoot an event category removed, and then all the products that contain that category or that category ID should be also removed. And then all the product variants that also fall into that category should also get removed. So you see, product category doesn't know. You can pretty much add it or remove it from the system, but these two will actually react to the changes. So let's have a look at the diagram, how it's actually done in the other way. So instead of having this as a reusable service, what we can do is to create a new app or library, and that's going to be the plan library. And then we're going to have the bus in here. And then we can say that in both cases, in the builder and Google Ads, what we can do, we can send an event saying footer clicked in this case. And in that case, in Google Ads, we can say start clicked. And now the plan can subscribe to both of these events. And whenever any of them actually appear, so let me show it like this, then it will show the model. So it's pretty cool, because if I decide to remove the plan for whatever reason, so I remove this, I also remove my handlers. Now, okay, sure, it's gonna shoot that event. Maybe some other module will react to it, but in the end, now I don't have to go to my builder and change anything. I don't have to go to Google Ads and change anything, and then I can set up very easy a triggering mechanism to actually do it. I hope that makes sense. So I can show you quickly in a code. So we have events running everywhere, and we're talking about 150,000 lines of code here. So it's not super big, but it's quite big actually. An idea is that, you see, we have different cases. So we have a module that is exposed, and then we have a application event handler. You can look into, oh, sorry, it's this one. You can look into it, and it's just an injectable, and then it has an event class. So this is the class that it can subscribe to. Whenever this class gets executed on the bus, it needs to know what to do. In this case, we say, hey, is the resource inside the builder? Well, it is. Then let me navigate. And this is another example. This is really powerful. An idea is probably it happened in your case so many times that you set up routing one time, and then the other team wants to execute something and redirect to your module. Well, you just tell them, hey, navigate to this route, whatever it is, A, B, C, D. And everything works fine until the first team decides to change the name of the route for whatever reason. Maybe they have new business requirements. They will never remember that you actually using that. I mean, there's no even way to check that statically in the code. So you will change that because that's what's in your ticket, and then you will actually end up breaking the functionality. So the fragility situation I described before. But in this approach, since the routing navigation is handled inside, because it's a BREX navigation, so it's going to be handled inside the BREX module, I will change it in one place because that's the team that deals with it. All I have to make sure is that I dispatch the event and they react to it. And if you have a look at, maybe we can also navigate to the example on GitHub. Here we go. So yeah, please do star it if you want. Actually, it helps us grow the open source here as well. So an idea is that you can have an application bus. There is something called event orchestrator. It's like event handler, but it's handle multiple events. It's actually very, very interesting. You might check it out. But look, it's pretty straightforward. So I have my bus, I have my events, and the way it works is on my application bus, it's very simple. Oh, actually, it's a subject. And then inside the subject, I can dispatch or I can subscribe to it. And it's all based on observables. So it's the RxJS law we all love. But I mean, it's really literally 10 lines of code, but it's so powerful. I mean, it's really good. And then you have two different interfaces, one for the dispatcher, one for the listener or event handler, if you will. And then you can play around with it. And then we have application, injection token. Injection tokens are really good. Actually, we really love them a lot. And then we can just use them. So let's have a look at the actual use case. So in here, I have categories. Yeah, no, sorry. Yeah, so I might have my event handlers, and then those event handlers will have the name of the event and then handle it. So in this case, I want to say, hey, product added event handler. So it's based on the product added event. And then here I can inject my local services. Since I'm in a notification service, notifications library, I have access to notification service. So I'm free to use it because that's high cohesion, right? This is part of my module, so I can refer it. But if you look here, you have no reference to the other libraries except for the events. But that's a core library. That's a different thing. It's like you would use the authentication as well. And then here, I just notify that. So it's pretty powerful. In the other case, you could use the notify service inside the other components. That's good for the small size, but as soon as you go bigger, that's going to create a lot of maintenance help for you. So I hope that was sort of descriptive. And this is how it really works. There is a plan service as a module loaded separately. And then if I click this, it triggers that thing for me. It's pretty powerful. So now I can actually add those handlers everywhere I have. So I can decide to add it here, and I can decide to add it here, and I don't have to copy the code or anything. It's literally one line of code. So this is very powerful. If you really have a loose coupling and high cohesion, you're gonna need to add only one line of code everywhere, and things will work for you. So let's talk a little bit more about those rules that you should follow while working with EDA. So one very important rule is events must not depend on other modules, which means you should bundle them in a core library. And then obviously all the rest, like in the example here, will have a dependency on that event. And that's okay, because this is just a core library that contains only those events, which are very simple classes. They don't contain any logic. Maybe I can show you an example. Look at this. It's very simple. I mean, it has some resource in here as containing an information, and that's it. But you see, it's really, really simple. It doesn't have any getters, any setters. It doesn't have any logic in it. It doesn't have any dependencies in the constructor. Just keep it as a data transfer object. And that's the second rule for the IDA. Kiss your events, which means keep it stupid simple. Don't add any logic in them, because they are not domain objects. They are not something that contains business logic. They are just data transfer objects. And then send only one event from each function. If you have to send more than one event through the dispatcher at any place, you probably do something wrong. This is the power of events, that it's one-to-many approach. So it's multicasting. It's broadcasting the information to all the modules that they can actually, if they subscribe to it. So use this to your advantage. Use only one event at a time. And then keep all your events in events library, as I already mentioned. So what are the benefits on the architecture? Well, the benefits is it's scalable, because you can add modules to event bus horizontally. You can just decide, I want to add 20 modules, and that's okay, because the command bus will handle it. So it's scalable. There also maintainability. Obviously, now you have really encapsulated logic in your libraries, in your modules. So you don't have to worry about dependencies outside, so it's easier to maintain. And you also get this technical flexibility of using any architecture you want inside. So your maintainability cost is the cost of the architectures you've chosen in the module. And then logability, well, isn't that great if I can log all the events that are happening in my application? Well, that's really great, because you can log everything that's happening, and it's in one place. It just takes one line where you say console log things, or maybe use Sentry or Datadog or whatever, log framework you use. But it's going to be in one place, and now you're going to log all your application logic. And then it's also testability. It's because you probably, when you code things, I don't know if you guys test. I'm really big on test, and I believe it's helping you as a developer big time. We're actually using test-driven development here. But an idea is, whenever you have a component or some state or whatever that has dependencies, you're probably going to end up stabbing a lot of dependencies. For example, I have a smart component. It has the service. Should be simple, right? Well, it's probably not, because that service can be HTTP service, which means it has a HTTP client, which means in order to test that component, HTTP testing client module, and that should be preferable actually. But look how many things you have to do just to start. Well, in IDA, you don't have to do it, because we provide you with a testing module. You can just add it instead of a normal module, and that's gonna do all the work for you. So you can listen, you can dispatch events from your tests, and test all the corner cases as well. So testability is better, because you don't have to stop so many ways, because you abstract away from dependencies. Sorry. So just a second, a little bit of water. So there are also benefits on developer experience. I think developer experience is very important. There's nothing worse than working in a legacy project and having to deal with a lot of mess in your code, and then start disliking your job more and more as you go. So this is why you should take care of the developer experience as well, because people want to be happy coding, not spend time on silly things. So benefits of EDA in developer experience approach is you simply have a lower cognitive load. So it's great because you don't have to worry about so many things. You just worry about the module you're working on. Sorry. And then architectural freedom. We developers, we like to choose what the tools we use. Go ahead and do it. It's also easier for debugging because you have the logs. So it's easy to just check it. Then for the business, because if you're still not convinced, or maybe if you are convinced, you have to convince your boss. So you can go to him and tell him, wouldn't it be great if I can tell you how my users use your product over time? Which means, in a typical example, you would have a snapshot of the data at the current moment. But in EDA, it's not like this. In EDA, you actually check what happened afterwards, and those series of events combine a state of your application. So that's really cool, because imagine this. Just imagine my behavior on this website. So I go to the website builder. Great. Now, this is a current state. Normally, you would just have information about it. But how would you do the undo redo part? I mean, you can't do it. So I add the text. Now I can undo it, right? It disappeared. And now I can redo it, and it appeared. You can't do it in the normal approach, but with EDA you can, because you just unfold the previous event. Now, if I change it and move it here, if I change the color, or if I do whatever, whatever I want. Now you look at this state of the application normally, and you say, well, the guy added a sample text, and that's simple case. But that's very often very little information for my product, because so many things happen in between. Maybe I click all the buttons, but then I decided, look at this, I decide to delete it. Now it looks as if I didn't do anything on this website, but I actually have. I done 4 actions in between. And I can tell that to my business. I can tell that all the users are deleting stuff they created. Maybe there is something wrong in the message of the product or whatever. And that's great, because I don't have only the latest snapshot of the state. I actually have all the states in between. I can even navigate back and see how users use my software. That way, I benefit from better product decisions. And then you can also experiment with the flow, because imagine this process to be a flow. It could be like like a wizard of the form, right? So I have step 1 and step 2 and summary page. Okay, let's remove all this thing. So you see, you can come to your business and say, okay, so there is a step 1, step 2, and summary. But maybe, I don't know, maybe I want to change that. Maybe I want to make step 1 summary and the step 2. Okay, maybe it doesn't make any sense. Maybe they would be called differently. But I can move things around very easily, because it's based on events, it's decoupled. So step 1 doesn't know about next step. It just knows it needs to send an event, and that in some global business process triggers the summary step. So I can remove the order of things very easily. So that helps me experimenting with the flow. It also means that feature flags are getting really easy. Feature flags is a whole another topic. It's really advanced. It's simple to do, but it's really advanced to understand. So I'm not going to talk about it. You can also check my YouTube for this. So by now, what have you learned? Well, I hope you learned about how to identify tightly coupled Angular app. And I hope you learned also what are the components of event-driven architecture, that we have an event bus, that events are at the core of everything, and they are very simple objects, and that there is an event dispatcher and event handler. And I also hope that you learned that how to implement EDA in Angular projects. If not, go into the repository and check it out. And I hope you now understand all different benefits for different stakeholders in your projects of using EDA. So with that, I would like to thank you. Again, my name is Greg. I'm CTO in Cobiro. here is the link to the GitHub repo. Check it out. And yeah, maybe you guys have some questions, so I would like to hear them as well.
Very much, Greg. Yeah, so if there's anyone has a question, please unmute yourself and ask away. Okay, let me just start off. So wait for others. So I think my question would be for so for those who are like beginners, right, who are just getting started in Angular, would you still advocate for using event-driven architecture at an early stage of let's say a beginner type of developer?
It is an advanced topic. Usually I teach it on the senior tracks and conferences. So I would say there are benefits, but maybe first master layers and master like the understanding of coupling. Maybe, you know, have a couple of issues with that first in order to seek guidance in EDA. But it's definitely worth to play around and just, you know, you might be a beginner, but you might also decide that, you know, I want to learn new things, and then that could be interesting toolset. You don't need to be mastering it, but it's good to know that it exists. And yeah, but it is advanced topic.
Okay. All right. Anyone else has a question? Okay. I think there was one. Okay. Yeah. Sorry. Yeah, Alex. Alex, are you there? Okay. Seems I wasn't able to ask the question. Okay. So I think probably the other question would be there's a question one of the attendees asked because they couldn't make it, was what does this mean for scalability purposes, right? Like, does this mean that I'll probably touch the code, for example, if it's the bus application section? Like, what does this mean for scalability?
Yeah, it's actually pretty good for scalability because you can scale horizontally. So it means you can add things in parallel without these modules don't know about each other. So it's pretty good. And whenever you need to change something, you really change it in one place. There is one exception though. When you want to change an event, then yeah, that is an expensive operation. But typically you don't do it very often. So you should be fine if you keep the rules I've just mentioned. But for scalability, it's great. It's really great. I mean, I've seen people using NGRX because, you know, the whole idea, where it came from was from the scalability point of view. So at Kobiro, we've been building using NGXS, which is also a state management system. But the issue was that it didn't scale. Like the problem was it created a lot of maintainability issues because there is no easy way to communicate in between the states. So I might have a state here, a state there, but they need to communicate sometimes. And that was the issue. So we started to implement our own implementation of NGXS approach to it with like a global state. And yeah, they propose you can use that, but it doesn't work. It didn't work for us at least. So hence we started to say, hey, what we really need and how can we make it smaller and easier to use? Now we give it to hands of other people. So they actually use it in Google as well. So it's also pretty interesting. So yeah, I hope that answers the question as well about scalability. It's great for it.
Right. Yeah, Alex,
have a question.
Go on, Shem. Go on.
All right, cool. So great presentation, and I have a question. So I've been exploring the whole like having a state service, and then probably can try and extend it, and it also have an aspect of events where you listen to the the state, and all the listeners will get to be updated. So my question is, it's some sort of what we call event-driven architecture, rather simple one. And you also stated that you use NGXS. So we kind of have small mini states in our application. So what are the drawbacks of having such an architecture? And yeah, so that's my question.
Well, what are the drawbacks? That's challenging, because if you use it right, it doesn't really have a drawback. It's because it's used for its purpose. What you might get confused when first touching on EDA is when you're thinking that you should actually use it as a state. It's not a state. It's not meant to contain state information. It's a communication protocol in between your states. So you still have your states, NGRX, NGXS, subject base, whatever, but it's not meant to contain information that persists. It's just something I should, it gets sent to the other places, and then it disappears. So the drawback would be if you actually wanna persist it, you start playing with behavior subjects and stuff like this, then you're not doing this right. So think about it this way: even if it's a state or just a component, it doesn't matter. What matters is it's just a communication. So something happened in my system, the other places needs to react to it. I hope that answers the question.
Yeah, it does.
It's used in combination, you know, with NGRX. So yeah.
Cool.
Anyone else was a question?
Yes.
Yeah, go on.
Okay. Thank you, Greg, for your presentation. Some time back, I had done something very small for events, an event emitter. I was actually using observables. It was something simple where different components would register to the service and be able to react to different events in the app. But of interest, something that I wanted to know, like where you are showing the demo on the app, whereby the user would add text, remove it, and you are keeping track of all those events. In case that the user deletes everything, you still have a trail of everything that happened. Of interest is, how do you keep track of that state? Are you using observables? Are you using NGRX? How do you store that state? And the other issue is I'm looking at the GitHub repo. How do you keep, how is the message bus? I can also call it like a message bus. How is it structured so that everyone is able to keep ear on what is happening in the event bus?
Yeah, cool, great. So the first part is, how do we actually store events, right? Well, event bus wouldn't really store it. It would just, it's just a mechanism to receive it and then broadcast it to whoever, or actually multicast it to whoever is interested. So that's the part, but we need to store it. I mean, one of the benefits, I say, is great logability. It could be in many ways. It could be in a ways of console log, pretty much. It could be stored in some logs that are shipped with your, infrastructure. So it could be stored in a log file. It could be sent as a Google Analytics thing, or it could be also just sent to the backend. We actually, the thing with the the undo redo, it's called event sourcing. It started with the EDA, and then we said, okay, we need to persist them. So we actually persist them in a backend in a database. You can use Firebase for this as well. So, but don't think like this is something source of truth from which I need to create a state. This is just something I want to stash my events to, because otherwise you might start blocking some rendering in your browser. So that might be the performance issue then. So just make sure you just throw it somewhere, stash it somewhere, and then later you can process it in some other process, if that makes any sense. And then the message bus is very simple. It's just a subject. It's just a behavior subject. pretty much.
Ah, all right. Okay, thank you.
Okay. Is there anyone else who has a question? Okay.